Hi everyone, welcome to IT and Automation and welcome to our Kubernetes tutorial series. In the past, we have looked into a bunch of different Kubernetes topics, and talking about the recent past, we have been focusing into scheduling decisions and how Kubernetes makes those evaluations during scheduling. And two of the topics we already covered is around pod disruption posit, pod priority, and pod topology constraints. And today I will be covering some of the aspects of node affinity and anti-affinity, and we can deep dive to understand more in detail. So in this video, we will explore how Kubernetes makes those scheduling decisions using node affinity and node anti-affinity. These concepts help you essentially get more control over your Kubernetes resources distribution and workload placement, where exactly your workload should be placed. So node affinity, right? Node affinity allows you to constrain which node your pod can be scheduled on based on the label on the nodes. So you have labels on the node. If you're familiar with the Kubernetes, you have a label around every resources. Similarly, you will have a bunch of labels on the nodes. It could be a vendor nodes. Say Amazon would have its own nodes, and any other vendor would have similar one, GCP, Azure, or there are Kubernetes defaults as well. It's similar to node selector, but node affinity, I would say, offers more expressive capabilities. Right? So node affinity allows pod to specify which nodes they can be scheduled, and again, as I said, based on the node labels. So there are two types of node affinity. Let's look into some of those next. So two types are required during scheduling, ignored during execution, preferred during scheduling, and ignored during execution. So required and preferred, those two terms that you want to look closely into. In this screen, I'm sharing required during scheduling. As the name suggests, this type of affinity is enforced during the scheduling process. If the node does not match that criteria, the pods won't be scheduled on that node. So in this example, API version for pod v1 kind pod, metadata example pod, and this is spec. That's what plays the key part here. In this spec, we're saying affinity type is node affinity, required during scheduling, ignored during execution. And we have a node selector terms which must match the expression key, disk type, operator, in values SST. So that means the pod can only be scheduled on the node that has a label called disk type and its value is SST. And Kubernetes will only place the node that has this type, which is what you're mentioning by putting this required during scheduling, ignored during execution label there, or attribute I should say. Whereas preferred during scheduling, ignored during execution is slightly different. This type of affinity is a soft requirement. The scheduler will try to place the pod on the matching node, but it's not guaranteed. Pretty much same, but the difference is preferred instead of required. So here, the scheduler will prefer nodes with disk type equals to SSD, but if none are available, it will still schedule the pod in a different node. That's why we call it soft. And as the term explains, it is preferred rather than required. So next topic is node anti-affinity. So as you can see on the screen, node anti-affinity, that is the manifest for node anti-affinity. It is opposite of node affinity, of course, right? It allows you to specify rules that prevent the pod from being scheduled. The previous ones we looked into is where we said we want pod to be in these nodes, but now with the anti-affinity we say is pod needs to be prevented from being scheduled. And we will look into the scenarios and the real world examples in the next coming few minutes. This is particularly useful for distributing your workload to avoid like a single point of failure. So you do not want scheduler to bin back all of your same application replicas into the same node. And if that node goes down, you have all of the pod down, and even if it takes a few minutes to come up in the new node, you still have that bad impression to the customers. So again, as I said, node anti-affinity prevents pod from being scheduled on a certain nodes based on the label. In this example, we are saying it is a required match expression is app where it is front end and you have a topology key. So what does that example mean? The pod will not schedule on a node that already has a pod with label app front end. You do not want two front end pod to be on the same node. The topology key here is hostname, as you see in the last line, which means that anti-affinity rule is applied at the node level. You could do same thing based on AZ, same thing based on region. So next one is real world application example. So let's talk about real world scenario here. Imagine you have a stateful application, right, that needs to be highly available, and you can use node affinity to ensure that pods are scheduled on the nodes with SSDs for better performance. And then use node anti-affinity to spread the pod across the different nodes to avoid that single point of failure. So you essentially, in this manifest, said, I want node affinity with required to be SSD and pod anti-affinity with the app in my app and topology being hostname, meaning do not place two pods with the same key app equals to my app in the same host. So you requested SSD here, and then you said don't place it in two in the same node. The deployment, this deployment will ensure that pod are never going to get scheduled in the same node, but it will put in two different nodes or three different nodes, depending upon the replica. In this example, we have three, so you have a three different. It will be placed into three different nodes. So to conclude, that's the quick overview of node affinity and node anti-affinity in Kubernetes. This feature basically gives you a fine-grained control over pod placement, and you essentially, by doing that, ensure that optimal performance and availability of your application. And to recap, we looked into Kubernetes scheduling diffusion, node affinity, anti-affinity, and a real-world application. If you found this video useful, please make sure you like, subscribe, and hit that bell icon for more Kubernetes tutorial. Thank you for watching.